search later.
Yeah, I got it.
Okay, let's be quick on this. Just from Keras, just write all this stuff. Once you're done, just tell me. Done? All are done? Writing this? Don't worry. This once we have to write, we'll use it again. Just type it out. Just type it out. Import numpy as np. If there's spelling mistake, you will automatically get to know. Import numpy as np from Keras.model import sequential. From Keras.layers import tense, comma dropout, comma activation, comma flatten, comma add. After flatten, there's add. Okay, it's not visible. Then we have Keras.layer. From Keras.layer import convolution 2D, comma max pooling 2D.
Like for example, Panda is made on top of NumPy. Like that, like so Keras do the same thing as a TensorFlow, or it is on top of it.
It's on top.
So it uses TF and all this.
Yeah, can you say on top?
Is it downloading something? No, for me, I don't know what is it saying. Downloading something.
So Keras would use all the things like TensorFlow and then on top of
Place
it,
this with us.
similarly, there is a PyTorch. So that is a different line of that doesn't have to do anything with the TensorFlow, and it has options.
I'm not using Sukan.
Okay.
We're done here.
Should be good,
From
huh?
Keras.datasets import
Okay.
MNIST.
Acha.
People who are not done, please raise a hand. Okay, next thing you have to do is now curly bracket, just normal bracket, x underscore train, comma y underscore train, comma bracket x underscore test, y underscore test equals to mnist.load data.
Okay, I think that's the reason it was downloading stuff. I had written one more line, right? That's why it downloaded stuff. Okay.
We're done here?
See, it should take like this. If you see. So first is initializing here. What I read.
So what is MNIST? MNIST
Next
is a
is
handwritten
this.
digits.
Yeah.
What you're taking the data from the source.
And
That is
this
the
what
data
we
set, I
use
think.
to make our
It should be a data set. On data set, we will apply the algorithm.
And what we have done, we have so load data is a function inside Keras where it has automatically divided into test train and test data sets. Or maybe it's there in the original database also. We're not interested in all of this right now. I just want you to proceed from here. And if you have done this, then write this guy. This is what you're going to write now.
What is here? Fine.
So we are using matplotlib as a plotting library, and this line is used to see the plot in your Python notebook. I'm not pasting more.
There is another channel which is created inside the MLD.
What is this percentage?
So that line is saying that if I'm using matplotlib, please draw whatever we are going to draw in the line, in the code. Otherwise, it's supposed to give you a new window. But because from browser opening a new window, sometimes security issues not go on. To process every block, just press Shift Enter. If you press Shift Enter, you will see this digit.
Five.
So what is this? Is this a kernel?
No, this is the image. Okay. So what we have done now, first we actually print the xtrain.shape, which is the dimension of the input which we are using to train. So x is the input we have, and we have 60,000 images, and each of that image has a dimension of 28 by 28. So we have 60,000 images of handwritten digits 1, 2, 3, 4, 5, 6, 7, 9, and 0. And then we are saying that, hey Plotlib, why don't you just draw the x train sample number 0? So if you say that to imshow, which is a function in matplotlib, we are going to get 5. So this should be same for all of you. You can change this number 1 from 0 to I think 59999, and then you should be able to see any image of the database. So just do it just once for yourself. Just change the number and confirm this. So you're seeing all the random numbers, all the random images you want. Okay, so before we proceed, we want to avoid max pooling and do convolution here, which means we want to avoid one person doing all of the work in a group and do convolution, which means each of you talking to each other and seeing whether you have the right weights or not. So I want you to confirm that person next to you is here, because if you're not here, stuck somewhere else, you're not figuring out, it's not good.
It's okay.
Anyone is stuck?
I'll be
You're stuck. You're stuck? No. Who's stuck?
I'm more interested to see this actually. How is the data set is?
Yeah. Let's see. Yeah, I've downloaded it. I mean,
I knew some other data sets. I was trying with R. So where is the
you already have a it's getting downloaded for you also.
I want some data sets already. I don't know where I get ENP.
Yeah, for me. I'll just paste it somewhere.
NPC has X, Y,
Did it open for you?
Yeah.
Okay, I don't know.
Maybe it's
In
Linux,
Mac,
right?
yeah, in
No, I
Mac.
have other things in my system. I'm working on some patent on compression.
Compression.
So compression and delta. So maybe some package would have recognized it.
Okay. So this is the
This is the binary or the image.
this is X train. This is a
Yeah.
what? X tester.
X test.
Okay.
Text train. This is the file I think. But what actually the train has mentioned.
PC.
This is the converted vector image I think. Internal files, numpy. It's a number zip format. It's a simple zip format which contains the numpy files.
That's the so total exchange shape, right? 60,000 samples. And each sample is 28 by 28.
If it is a just number,
So 60,000 images, 28 by 28.
um, this is which format? Is it a vector format of an image or?
Sorry?
Zero.
It's spread across 3 different ones. So I'll explain while I'm going. Okay, so we are together now. You want 1 more minute back? Okay, why is this important? Why did we print the shape of this input sample coming in? This is important because the first, right now all the packages are good enough, so if you can just add a new layer, keep on adding layer without thinking what is the dimension at that layer. You do not have to calculate. In Cafe you have that in TensorFlow, we had to do that. Now everyone is automating that. Keras is, from that point of view, easy. You do not have to think anything. Just continue writing, you do not have to see after this point how many pixels are coming in. You can just continue to start. We'll see that. But we need to know that what is the size of the input image coming in. Because if you take a kernel of 50 by 50, what will you convolve on? So we need to know those multiplication factors later on, not right now. But this is just for our information that we have 60,000 images, 60,000 samples of digit 1, 2, 3, 4, and then 28 by 28 size, and this is one of the samples. If you count the number of pixels here also, you find 28. So it's 25 here, 26, 27, and then 0. Now I want you to write this line.
The whole data set.
Hmm.
You can change that to shape so the two numbers can be used. So two blocks.
So this is reshape. Reshape is essentially to take a sample of any matrix from let's say 4 by 4 and convert it into some other space 2 by 4. 4 by 4 is 16, so it has to be 2 by 8. So both the things have to match. So it's basically taking a matrix and scaling, transforming it into some other shape. But the area has to remain same. So multiplication factor has to be same. That means if you are taking this shape, you can do something like that. But you cannot do something like this. You can take this thing and add one more on the bottom. So area has to remain same. That is what reshaping is. So for some reason, Keras in the new model changed the format of this. This used to be earlier 12828, but the new Keras is doing 2821. So it has nothing to do with the stuff which we are doing. This is just to make sure that the program doesn't crash. So not important, but reshape we'll use later on if we have to change two-dimensional data into one-dimensional data. Initially you are asking, right, why do we only have one-dimensional data as an input? If you were to do that, this is what you will do. You'll have 2828 as input data coming in, but you will say reshape my train 28 by 28 data into 0. 28 into 28 here, comma 1.
Comma 1 stands for?
That 1 stands for that this is the color channel. So you're telling the channel. This in Keras is the new format where you're telling the number of channels. If you had RGB, you will have 3 here. In earlier examples, the 3 would come here. Just a format in which we're telling that this is how our train data looks like.
So this is a 2D.
It's a 2D. 2-dimensional, only grayscale, 1. If you had RGB, we'll have 3 here.
It's a vectorized future actually for each number of images.
So the Xtrain is what we got from MNIST. MNIST is a database which is stored on AWS server of Keras. So we downloaded MNIST from there, and then we have assigned Xtrain and Ytrain all the variables. But the way Keras take those variables is slightly different. The way Keras take those variables is that we have to realign the channel number on the last column, the last parameter. So the way we have data right now is 12828, but the way it needs is 28281. Not important. This is just following syntax. It's like in C you have to add a semicolon at the end, Python you don't. That sort of stuff.
But the extent we get is 28 by 28 for
Same. Yes.
And so here, do we need to have this?
No, we are not doing 1D. This is 2D. Proper 2D to 2D. Okay. Next, I wanted to write this specific line. This one. So Xtrain. So MNIST is a database of numbers. In OpenCV or any programming language for graphics or in graphics, each color is represented as a number between 0 and 255. So right now, all the data we had from MNIST is from 0 to 255. So the first thing we do in any neural network is to assign or rescale all of them between 0 to 1. Now, if I take integer value, which is 43, so it's one of the color in 43, and divide by 255, I'll get 0. Because in integer it's either 0 or 1. So we have to change it to float also. So what we are saying is, take the Xtrain value, first convert it to float. So now I have 255.0, 43.0, same value we had. But now we have converted to float, this first step, and then divide by 255, because we want to rescale them between 0 to 1. So if you were to see these images, all of the images will be black, because it has all the values between 0 and 1. Even though it has all the values, but you will only see black. Because OpenCV or any programming language wants to see back into 55. So if you want to see these images, what will you do? First thing is to multiply by 255 and then convert from float to int. So same reverse of that. So Xtrain into 255, then Xtrain equal to Xtrain.as type, where we type conversion and write float int 8. Only these 4 lines.
Again, I want to see that data. Would have we got an error?
Yeah.
Divide by 255.
For you?
Yeah.
Xtrain equal to Xtrain dot reshape Xtrain dot oh shit.
Not reshape. Okay. Shape. Okay. Reshape spelling are again wrong. Here, just check Xtrain wala. Reshape EE. So what is it to
That is written by where are we right now?
So as we are normalizing the X one, we also normalize the target value also.
We do that next step.
But why you doing X rate divided by because it's already black.
Already black.
It's already
Black and white, right? But it's an integer value. So the blackness is how black is it? With
0 to 1. 0 to 1.
0 to 1. Just rescaling. And we cannot just do a scale from 0 to 1 of 0 to 55 if it is an integer. So you have to convert it to 4.
can you show me the dataset once again? I just want to see are those number when
So people who are at
this
A,
is an
please raise their hand.
hexadecimal.
This is an example.
People who are at B, please don't raise their hand. B means you're stuck. B means you're stuck, okay?
These images will be converted to hex.
Okay.
Whatever we take.
So I didn't understand. I mean, 60,000 images. So that data that we are seeing, right, train wala, is that all 60,000 images?
Yeah, it's a combination.
X coordinate only. Only X coordinate because we have X and X. Oh, we don't have Y, right?
No,
No. We do have Y train and Y. So what exactly is that? Then?
no, it's actually like you are taking an image, passing like this X strings.
Sometimes.
So I
It's
take
like the
But it will not
X
this
coordinate.
image is converted to hex. You
Yes.
can ask him.
Yeah.
What actually this data set is. Can you
because all the loss functions, ReLU, etc. are designed to work around zero. So how do you get negative percentage? If you are already from space of 0 to 55, 1 to 55, you only have 255 numbers to play with. If you go in float, you suddenly have 100 million numbers to play with. What is the value of 43.4 for some specific stuff? How do you add that? It does not have 43.5 because it's always integer.
What if we just convert it to
After
Because we want 43.5 also.
we keep it the same, but we convert the integer to
Then we'll have 0, then we'll have 43.5. But then what will happen while trading? It's going to get multiplied with very small number, which is 10 to minus 3. And when that happens, some of your numbers will get multiplied with large values, some will get multiplied with less values. So the normalization will be very different. Even though it learned value, let's say it learned a value of 3, which was very important. So in the scale of 0 to 55, 3 is very less. But had I scaled all of them, the 3 will not be 3, it will be 0.7, 0.8.
Maybe you would have learned some other thing. Maybe 30, you would have learned 30.
It will learn 30, but then your loss function is on 255. Your loss function will be a bigger number. When you scale everything between 0 to 1, you can say that the loss function is close to 0. But if you have a scale of 0 to 55, what will you say about good loss value? 4, 5, 8,